Hi, this is PH 5502, Unit 4, Solid State Physics by Dr. M. R. Gadhvi. In this chapter, we will be discussing the theory of electron free gas, or it is also known as a free electron gas theory. So basically, this entire theory was not for a general or any random element of the entire periodic table, but it is limitized to the only metallic crystal. माने सिर्फ और सिर्फ ये मेटेलिक क्रिस्टल के लिए ही बनी हुई थियरी है. ओके, नाउ what basically the scientist is highlighting in this particular theory, the electron theory of a free gas or the free electron gas theory was basically explaining the structure and the property of the solids through their electronic structures. So you pick up any particular metallic material and looking to that electronic structure, we can speculate about their structural property, their electrical property, their physical, rather in broad sense I can say it's a physical property, right? It carries the structural property, it carries the electrical property, it carries the thermal property, and so on. So according to this theory, a metal can be considered as a consist of an iron core having the nucleus and electrons other than the valence electron. These valence electrons form an electron gas, surround the iron core and free to move anywhere within the metal. This is very well known things, right? कि metallic crystal में wherever there is a metallic bond, so wherever there is a metallic bond, so the valence electrons are referred as a delocalized electron. A very nice name is given by one of the author of the solid state physics books, that is M. Ali Omar, and he claimed it as a delocalized electron. That means it is not localized to any particular host ion, so it is roaming throughout the crystal. So they tagged as a free electron. So, or in other words, it's a valence electron. So valence orbital electrons are referred as a free electrons, and that's why they are moving within the entire crystal of the metal. They are put analogy of an electron gas surrounded in the iron core. The electron theory of a solid has been developed in three main stages. The very first stage, that is a classical free electron theory. The very first model was represented by Drude and Lorentz. Paul Drude and Lorentz developed this theory in some around 1900. So it is just beginning of the 20th century. And according to this theory, the metal containing free electron obeys laws of classical mechanics. When I talk about the classical mechanics, that means I have to put an analogy of this electron or particle, and I am putting an analogy just like the particle of a gas or molecule of a gas. And if, because I am tagged as a electron gas, and once I am tagged as a electron gas, I have a freedom to have an analogy with the kinematic theory of the gases, or rather the kinematic theory of an ideal gases, and therefore the classical mechanics can be easily adoptable over there. The second logic of this particular free electron gas theory, that is with the quantum theory, and this quantum free electron theory was given by Sommerfeld, Sommerfeld in some around 1928. In 1928, so almost after 28 years, the another scientist has given the idea about the quantum concept. In this quantum concept, they introduce the logic about the quantization, and once the quantization concept is introduced, uh, the many arguments of this theory was nicely argued by many properties are nicely argued by this particular theory. The third phase of the theory is given by the zone theory. The Bloch stated this theory in almost in the same era, so 1928, and according to this theory, free electrons moves in the periodic field of a provided by the lattice. We had learned in the SYBSC that there is the crystal is basically made up of a two part lattice plus basis. If you do remember, I have given the definition in your second standard for any crystal. So how one can understand the crystal? Crystal, that means lattice plus basis. Basis, that means a group of atoms or molecules, and lattice, that means it is a mathematical analogy, a mathematical model, a mathematical treatment where you can assume or presume about the availability of an atom or molecule in a three-dimensional space. So three-dimensional space, mathematically, that is a lattice where you are assuming or presuming the availability of atom and molecules. So this is a lattice, and on a lattice there is a periodic repetition of a group of atoms or a group of molecules, and which is referred as a basis. So this periodicity on a lattice is observed in any particular metallic crystal. And once you have a periodic metallic crystal, so basically what is metallic crystal? The electrons are spreaded through, I mean the core electrons are localized, but delocalized electrons are spreaded throughout the crystal. So they are not associated to any particular host or a single ion. And this model is purely understandable. There is a periodic repetition of a ionic core, and therefore there is a periodic potential, and therefore this electron gas is doing a movement in a periodic potential wells, and that is theory is given by the Bloch theory, or it is also known as the zone theory, or I think a band theory is very well known word, and you might have heard that as well. So how it looks like a jelly model or a bean model, that what I said, it's a the all positive ions are a metallic core ions, and electrons are making a cloud around it. So it's a very uniformly spreaded throughout the crystals. If you look at here it is tried to give the uneven picture, the hazy picture of this one, and that is representation of a positive, I mean the electron clouds, the background one, which doesn't belongs to any one particular metallic ion, because this negative ions is basically belongs to, no, we can't claim it's belong to this, it could be of anyone. So it could be of any one ion. This is just a two-dimensional picture. You have to also visualize as a third dimension, which is in the depth. You have to also visualize the third dimension, which is coming out of this particular reference frame, and that is one. So this basically a positive ion, and that is spread out throughout the crystal. Now what is Drude-Lorentz theory? He, before he putting up, see, on in any particular model there is always some postulate, there is always some assumptions, and then only the scientist will give us some model on basis of that postulates. So Lorentz and Drude has given us some postulates, and that is number one, in an atom electron revolve around the nucleus, and a metal is composed of such atom. तो मेटल है वो ऐसे ही एटम का बना होता है जो हमने एटमिक मॉडल में विजुलाइज किया है. द इलेक्ट्रॉन्स आर मूविंग अराउंड द न्यूक्लियस, एंड देयर इज अ वन न्यूक्लियस इन द around which electrons is revolves. द सेकेंड पोस्टुलेट ये है कि वैलेंस इलेक्ट्रॉन्स ऑफ द एटम्स आर फ्री टू मूव, माने लास्ट ऑर्बिटल इलेक्ट्रॉन्स दैट इज अ वैलेंस इलेक्ट्रॉन्स एंड दैट इज वेरी मच फ्री, and that is what a better word I can say, that you can use the delocalized electron during the entire crystal, or you can say during the whole volume of the metal, like the molecules of a perfect gas in a container. कोई एक कंटेनर के अंदर जैसे गैस के मोलिक्यूल्स रोम हो रहे हैं ऐसे ही ये रोटेट होते होंगे. ओके, नाउ from all the atom in the given piece of a metal from the electron gas, it is a free to move throughout the volume of the metal. From this atom, it is given a piece of metal from an electron gas, it is a free to move throughout the volume of the gas. माने ये जो इलेक्ट्रॉन्स है वो पूरे के पूरे मेटल में कहीं पे भी घूम सकते हैं. The third postulate what we can think of, this free electron are randomly directed. So when they are moving within a crystal, it is not predefined motion, it is a random motion of electrons, and if it's a random motion there is a chances of they collides. Now when they will collides, there is a possibility of two things of a collision. One thing is either they have positive ion and fixed to the lattice, तो या तो वो लेटिस पॉजिटिव आयन के साथ कोलाइड हो सकते हैं, और देर इज़ अ फ्री इलेक्ट्रॉन. सो माने दूसरा एक फ्री इलेक्ट्रॉन दूसरे फ्री इलेक्ट्रॉन से कोलाइड कर सकते हैं. सो देर इज़ अ टू पॉसिबिलिटी ऑफ अ रैंडम डायरेक्शनल कोलिशन. वन कोलिशन इज पॉसिबल विद द पॉजिटिव आयन इटसेल्फ, और दूसरा itself own, that is a free electron gas itself. But this collision, they are saying that there is no loss of energy. That means it is considered as a elastic theory or the elastic collision. Okay, now this movement of a free electron obeys law of a classical theory of gas, kinetic theory of gases. Okay, so I think in the last slide also we had discussed कि we have an analogy with the kinematic theory of the gases, or ideal gases, right? So that is what a classical kinematic theory of the gas is, and that is you can elude it. When you say that it is a equivalence of a kinematic theory of gases, so naturally the Maxwell Boltzmann distributions, you can adopt the statistical concept of a Maxwell Boltzmann distribution, especially of the, they will follow the Maxwell Boltzmann distribution of velocity, right? So electrons will follow that Maxwell Boltzmann distributions. The electrons moves in a completely uniform potential field due to the ion fixed in the lattice. तो अगर वहाँ पे आप देखो तो in metallic crystal there is the ions are periodically repeated. आपने last to last slide में देखा था कि ion is periodically, एक यहाँ पे ion है तो after just lattice length of a there is another ion, उसके बाद और lattice length पे एक तीसरा ion. अगर y axis में जाओ तो वहाँ पे भी lattice length में वन आयन, अगर डाउन वायु में जाओ तो भी एक लेटिस लेंथ में, अगर नेगेटिव लेंथ एक्स में जाओ तो भी एक वही लेटिस लेंथ पे एक पॉजिटिव आयन. सो वेरी मच periodically arranged all electrons, so the electrons moves in a completely uniform potential field due to the ion fixed in the लेटिस. तो आयन की जगह आप फिक्स सोच रहे हो और पीछे क्लाउड की तरह वैलेंस इलेक्ट्रॉन का क्लाउड पूरा घूम रहा है. सो व्हेन इलेक्ट्रिक फील्ड इज अप्लाइड टू अ मेटल, फ्री इलेक्ट्रॉन विल गेट एक्सेलरेटेड, and naturally the acceleration, because it's a negative charge, so the direction will be opposite to the direction of the applied field, right? तो फील्ड की दिशा से विरुद्ध दिशा में उसका एक्सेलरेशन जनरेट होगा, क्योंकि आपका जो पार्टिकल जिस पे आप बात करें वो नेगेटिव चार्ज है. यहाँ पे आपको एक बात ट्रिगर्ड होनी चाहिए. सो लास्ट स्लाइड में मैंने बताया कि यू हैव टू इलेक्ट्रॉन वेलोसिटी इन अ मेटल ओबेज द क्लासिकल कंसेप्ट of a Maxwell-Boltzmann distributions, which is a pure concept of a classical theory of a kinematic theory of a gases. अब यहाँ पे आइडियल गैस का मोलिक्यूल जो है that is a chargeless, whereas electron is with the charge. But though we are considering their velocity concept with the Maxwell-Boltzmann distribution, but still because it is a negative potential charge entity, it is sensitive to the electric field, and therefore जैसे ही lattice पीरियोडिक पोटेंशियल वेल में या तो आयनिक पोटेंशियल लेटिस में या तो उसकी आयनिक पोटेंशियल मैसेस में वो इलेक्ट्रॉन मूव करता होगा, सो नेचुरली देयर मूवमेंट विल बी seen by the potential because of their charge availability. तो यहाँ पे थोड़ा सा deviations of the postulates which is assumed by the Drudd and Paul Drudd and the Lawrence, वो दोनों के कंसेप्ट में जो कंसेप्ट आप सोचा था कि वो एग्जैक्टली एनालॉजी ऑफ द काइनेमेटिक थियरी ऑफ आइडियल गैस है, ऐसा नहीं है, क्योंकि गैस का मोलिक्यूल चार्जलेस होता है और यहाँ पे जो आप इलेक्ट्रॉन क्लाउड का गैस या तो मेटेलिक क्रिस्टल का जो वैलेंस इलेक्ट्रॉन से बना होता एज्यूम्ड क्लाउड है, दैट इज़ हैविंग अ नेगेटिव चार्ज, और वो नेगेटिव चार्ज है तो दैट विल बी डेफिनेटली अफेक्टेड बाय द पोटेंशियल, और अगर वो पोटेंशियल से अफेक्टेड है तो हम आइडियली काइनेमेटिक थियरी ऑफ गैसेस ब्लाइंडली अप्लाई नहीं कर सकते हैं। तो यहाँ पे एक थोड़ा आपको दिमाग में आना चाहिए कि अगर कहीं पे भी थियरी में मिसमैच जनरेट हो रहा है तो वन ऑफ द रीज़न इज़ दैट बिकॉज द स्टैटिस्टिकल tool what you have adopted, that is a Maxwell-Boltzmann statistics, which is not 100% fully fit to our existing model. हमारा जो मॉडल है वो चार्ज्ड गैसियस क्लाउड है, और हम जो स्टैटिस्टिकल मॉडल सोच रहे हैं वो चार्जलेस या तो विदाउट चार्ज वाले स्टैटिस्टिकल मॉडल के लिए एनालॉजी में से कंपेयर कर रहे हैं. सो दैट इज़ वी हैव टू ऑलवेज थिंक ऑफ. फिर भी this model was काफ़ी successfully, very much successfully, and what we have observed it is verifies the Ohm's law. जितने भी metallic crystal थे उसमें जो भी Ohm's law are sensitive, which is nicely observed and verifies the Ohm's law within that. And to be very interesting point of that कि 1900 में कोई भी मॉडल अवेलेबल ही नहीं था. सो ड्रड एंड लॉरेंस का मॉडल उस वक्त का द ओनली वन मॉडल थ्रू विच वॉट एवर यू कैन स्पेकुलेट फॉर द थियरी पार्ट ऑफ एनी पर्टिकुलर मेटेलिक क्रिस्टल. तो मेटेलिक क्रिस्टल का थियरेटिकल पोर्शन विजुलाइज करने के लिए एक ही ये पॉइंट था. दूसरा इम्पोर्टेंट इशू ये देखने के मिला, इट एक्सप्लेन्स द इलेक्ट्रिकल एज वेल एज द थर्मल कंडक्टिविटी. काफ़ी साइंटिफिक सोसाइटी ने रिसर्च करके रखा था. कॉपर को हीटअप किया, उसकी थर्मल कंडक्टिविटी मेजर की, कॉपर को हीटअप किया, उसकी इसने इलेक्ट्रिकल कंडक्टिविटी ली, जिंक को किया, स्टील को किया, आयरन को किया. ऑल एंड एवरी ट्रांजिशन मेटलिक सीरीज आर completely surveyed by the scientific society, but unfortunately in 1900 there was not a single model, and once this electron free gas model or electron theory of a free gas is just entered in those years, it was very super duper hit, but it was not an ideal model. So सभी के लिए वो स्पेकुलेट करना नामुमकिन था. But anyway, you can definitely explains the electrical and the thermal conductivity. It derives the Weidmann-Franz law. What is that? Weidmann-Franz law क्या है? That is basically a relation between the electrical conductivity and the thermal conductivity. तो कोई भी मेटेलिक क्रिस्टल का इलेक्ट्रिकल कंडक्टिविटी एंड थर्मल कंडक्टिविटी का रेशियो लेते हैं, और अगर वो रेशियो अगर आप लेते हो तो सभी पैरामीटर विल बी कैंसल्ड आउट एंड सम कांस्टेंट इज कम अप. एंड वेरी नाइस पार्ट ऑफ that constant is uniform for entire range of the metallic part. So Weidmann-Franz law is very interesting. If you are doing your MSc in our Xavier's college, we have placed that model, an experimental tool in your MSc. You will definitely come across with this one. Even you can we will definitely derive a theory. You can definitely work out on the Weidmann-French law as well. It explains the optical property of the metals also. So these are a few points, very few points I have just narrated to I give you an idea that what is the importance of the electron free gas theory in those days. With this I end up over here. Thank you so much for paying attention. Stay home, stay safe.